Welcome to Areas of Triangles and Parallelograms. First, what we want to do is take a look at your area formulas. All of these formulas are based on the area formula for a parallelogram, base times height, because a rectangle is a parallelogram, so you do base times height on that one as well. And a square, since both of the sides are the same, that's why we have a side squared. Thing that you need to watch for is in a parallelogram where the height is. Please notice that your height is determined by the right angle that you see marked. So in a parallelogram, if here's your parallelogram, your height might be out here. Your height may be inside. Anything that you see with the right angle, that's going to represent your height. So this could be the height of the parallelogram, and this could be the height of the parallelogram. Triangle is just half of that. So you can do base times height, you can divide by 2, do 1/2 times base times height, any one of those forms. But again, your height is determined by the right angle. So any type of triangle here, we could have a triangle here that has your right angle down there. You could have an obtuse triangle. You could have your height on the outside, just as long as you're looking for that right angle marking. So let's go ahead and try some of these. We're looking at finding the perimeter and area of this triangle. Remember, perimeter is when you add up all the sides. So your perimeter, we got a 17, a 21, and a 10 would equal 17 plus 21 plus 10. So that would give you 48. When you do perimeter, if this were all measured in inches, then the unit on your perimeter would just be 48 inches because we're just walking around the shape. Now area, you have to look and make sure that you're using the correct formula. Being that this is a triangle, area equals 1/2 base times height. So your height, remember, is determined by the right angle. So this is the line that has the right angle, so that 8's going to be my height. Your base is going to be the side that this is perpendicular to. So if here's the right angle, your base would have to be that 21. So 1/2 times 21 times 8. So you can put in 0.5 times 21 times 8, or you could do 21 times 8 and divide by 2. So our area on this one is 84, and if we were looking at these were inches, your unit would be inches squared because area is always in square units. So now that's our most basic of problems. Next one, we're going to look at this. We have a rectangle. So we have a rectangle and we know area just equals base times height. Well, if we look, base, well, we could technically use this 15, but my right angle here, I don't have the length of that side. So what we need to do is think, well, how am I going to find the length of that side? Because this diagonal is definitely not my height. Well, hopefully you can see that there is a nice right triangle here. So I can use my Pythagorean theorem. If there's my right angle, it points towards the 25. So the 25 is my C. So off to the side, I'm going to do 15 squared plus x squared equals 25 squared. So 15 squared is going to be 225 plus x squared. 25 squared is 525. Subtract the 225 from both sides. I get x squared equals 300, and then I need to square root that. So the square root of 300 would be approximately 17.3. So we're going to use 17.3 for that height. So my area for this rectangle would be 15 is the base, 17.3 is the height. So 15 times 17.3 would give us 259.5. So this is where else you could use your Pythagorean theorem. Next, we're going to take a look at a problem where we have a shaded region. So this is the kind of area problems that we get into in this class. It's not just one shape, it can be more than one shape. So what you have to do is find area of both of these shapes. Here's kind of the standard rule. when you see more than one shape. If everything is shaded, then you add the areas. If it's part shaded, then you subtract your areas. So that's just kind of a standard rule that we'll be doing the rest of this chapter. If everything is shaded, you add your areas. If part of it's shaded, you subtract. Now let's go back to this problem. We need to see what kind of shapes we see. Well, I see a little triangle here. So here would be a triangle, so I need to find area of the triangle. And I also see a rectangle if I kind of ignore that triangle in the middle. So I need to find area of that rectangle as well. So if we look at the triangle, area equals 1/2 base times height. Well, if I look, I really don't have any measurements written on this triangle at all. But I know this is a rectangle, so whatever length is at the bottom is also at the top. So my base of that triangle should be 38. Now we also have to find the height. Well, in this rectangle, or in this triangle, I can go from this vertex perpendicular to the base. Well, if I know from the bottom of the rectangle up to that point is 8, I also know the entire length of this side is 15. So I can do 15 minus 8, which would give me 7. So the height of that triangle should be 7. So what I'm going to do, I'm going to do 0.5 times 38 times 7. And that gives me an area of 133. Then I'm going to go to the rectangle. Area equals base times height. So my base here would be 38, and I'm going to use the entire height of 15. So 38 times 15, which gives me 570. So when I look, I got to figure out which standard rule do I need to use. Is everything shaded, or is only part of it shaded? Well, only part of this one is shaded, so I have to subtract the areas. So I'm going to take 570 and subtract 133. And that's going to give me my total area. So 570 minus 133 would give us 473. And since it's area, it would be millimeters squared, or square millimeters. Let's look at one more problem like that, because these are a little bit harder. So now I have another problem here. I need to figure out, well, what shapes do I see? Well, I see a right triangle, I see a parallelogram, and then I see an obtuse triangle. So let me write that down. I got a right triangle, I have a parallelogram, and I have an obtuse triangle. So I'm going to have to find all of those areas. With a triangle, remember we have area equals 1/2 base times height. So if I'm looking at the right triangle, I have a nice right angle, so I know I do have my height here, which is 12, and it's perpendicular to the base here of 11. So it'll be 1/2 times 11 times 12. And I get 66. My parallelogram, area equals base times height. I know my base is 22. Well, my height, I have to find a right angle. The only right angle I see is over here. But if you see, that line does reach from the top of the parallelogram down to the bottom, so that would also be the height of this parallelogram. So 22 times 12 would give you 264. The last one, we have the obtuse triangle. Again, area equals 1/2 base times height. So I see my base here is definitely 8. But again, I don't see a right angle. But if I look over here, again, my only right angle, it still reaches from the top of this triangle down to the bottom. And so that would still be 12. So the 12 was the height of all three of these shapes. So now I do 0.5 times 8 times 12. And that gives me 48. Now, since I have the three areas, I do need a total area here. So we need to look and see, is this thing all shaded or only part? I see that it is all shaded, and which means I need to add all three of these areas together, and that's going to give me my total area. So I take 66 plus 264 plus 48, and that gives me a total of 378. Since it's measured in inches, your unit would be inches squared, or square inches. Now if you would take a look at these two problems and see what we can do.